Welcome to this lesson on optimization via gradient search in R. The very first thing you'll need to do is to load a little program that we've written for you, or that Project Mosaic has written for you actually, in order to help you do gradient search. And that command is fetch data. You know the fetch data command, but the thing you're going to fetch now is a program called mgradsearch.r, so you can execute that command. And the next thing we're going to do is create a function that we'd like to optimize. So I'm going to execute this function here, f equals rfun, tilde x and y, seed equals 10, n equals 3. So don't worry too much about this command. What it does essentially is just generate a random function that we can try to optimize. So this creates kind of a random function of two variables. And then we can do the mgrad search command on the function f, and you see what happens is that an empty plot opens with a little control box here. Now, here's what I'd like to have you imagine is the problem we're trying to solve. I take you and I drop you in the middle of a big, huge national park, and you don't have a topographic map, you can't see the whole park from where you're standing, and I tell you you're supposed to find the highest point. So one thing you could do is you could just do the least intelligent thing possible, which is run from point to point, measuring what your height above sea level is and just waiting until you find the highest point. And so this is what we're going to do by having this value optimization type selected up here. It's going to let us just click on points, and we can't actually see the topography of our function. It's a big blank slate, but every point we click on, we'll be told the height above sea level there. And we can ask, is this the highest point? 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 And as you can see, this is pretty inefficient, which should be in line with your intuition. So the question is there something more intelligent we could do? And now I want you to think about how you might actually solve this problem in reality. If I put you in that national park and said, find the highest point above sea level, what you would probably do is start walking uphill. And you might walk uphill for a little bit, and then you would look around and you would say, figure out which direction is the steepest uphill direction from there, and you'd walk a little bit in that direction, and you'd ask the same question again. What you're essentially doing there is gradient search or gradient ascent. Right? And so the point is that even though you don't have a topographic map, you don't know the values of your function everywhere, what you can always do is look at the immediate neighborhood around you, figure out which direction is the steepest uphill direction, that's the same as the direction of the gradient, you take a step in that direction, then you ask yourself the same question again from your new location, what's the steepest uphill direction? Right? So the idea is even if you don't know a function, you can look around you, figure out the gradient, and walk in that direction. And so we're going to have R do this for us. I'll run this grad search command again, clears out the plot. We're going to take a step always in the direction of the gradient, and when we click on a point, we'll be shown a long line that says what the gradient is. So I'm going to select gradient optimization. I'm going to click here. Here's the gradient vector. I take a little step in that direction, maybe this far. Okay, here's the new gradient vector. I take a step in this direction. Take a step in this direction. I'm going to get bolder and take bigger steps. And we can keep doing this, clicking at new points, taking steps in the direction of the gradient, and suddenly I get into this situation where the direction of the gradient seems to be switching around a lot. When that happens, it means that I'm probably near a local extremum, in this case, hopefully a maximum. And what I'm going to do is I'm going to say center on current point, and I'm going to zoom in a little bit using this bottom slider. Okay, so you can see the values of the function. I click here, it's about 10.2. I click here, it's about 10.2. This means I'm essentially at the hilltop. And there's no single direction that's the right uphill direction because we're standing basically at the exact top of the hill. And so now if I want all to be revealed, I can ask to actually see the topographic map. So I'm going to click Show Contours, and I'm going to increase the transparency a little bit. And you can see that we're in the middle of a big hilltop, and that indeed we're inside this 10.2 contour, and that's the maximum value of the function. Now, of course, we could do the same thing in reverse if we wanted to instead find a minimum, go to the lowest point. So what I'm going to do is I'm going to clear things out. I'm going to run a gradient search again, and I'm actually going to start around where that hilltop was that we were at before, but now I'm always going to walk in the direction opposite the gradient. And it's going to lead me downhill And I keep doing that. And we're taking a very efficient path, one hopes. And now I get into this situation where the direction of the gradient seems to be changing a lot, even when I take tiny steps. So I'm going to center on the current point. I'm going to zoom in a little bit. And I'm going to see that, when I start doing this, the function values I'm getting are all about the same. They're all about minus 3.09. So I'm assuming that I found my local minimum. I found my valley. And I can ask to now see the contours and see if we were right. Increase the transparency a little bit. And indeed, you can see that we're inside a group of contours at the bottom of a valley, and the minimum value is about minus 3.09. So that's how gradient ascent and gradient descent, which are both types of gradient searches, work in R to find local maxes and local mins. Thanks for listening.